In the previous videos, we saw a number of ways that we can use the implicit animations in Flutter to achieve a variety of different results. However, they do not serve every specific need. As an example, there might be situations where you would like to create your own implicit animation. And for that, we have something that's called a tween animation builder. And in this video, we will be making our own custom RGB slider to create our own custom colors. And this is a tween animation builder, and it's essentially our own custom implicit animation that we will make. But before we jump to the fun part, let's quickly explore what a tween animation builder is. A tween animation builder is a widget that animates a property of a widget to a target value whenever the target value changes. So that is essentially an implicit animation. However, the difference is that now we are animating a tween, and a tween can basically be anything. As an example, we can have a color tween, a rect tween, or even a tween of type double. So this widget allows us to animate a begin value to an end value of any given type. This will be good for animations that only occur once, or animations that are dependent on some user-controlled value. So before we jump to the color slider example that I made, let us actually explore the example on the Flutter website. And I've already taken this code that they give us, and we will explore this. So let's hit run. And as you can see, once it initializes, this icon goes from 0, and then it expands to a size of 24. So the target value is set to 24, and you can see that we pass in the target value as the end for a tween of type double. And this is within a tween animation builder. So this is what we want. We want to create a tween animation builder. We want to give it a tween, and then the tween will have a begin and an end value, and it will animate from the begin to the end. However, if we change the end value, then the tween will automatically update again. So as an example, you can see that this is an icon button, and this icon button, when clicked, will set the target value from 24 to a value of 48. So let us click this, and now you can see it expands from 24 to 48. And the same happens if we click it again, it goes from 48 to 24. So that means we can change the end value, and then the tween or the tween animation builder will automatically interpolate or animate between the end value that it currently is to the new end value that we provide. And to trigger a rebuild, you will see that the target value is handled or changed within a set state call. So we are calling set state, and then we are just changing the target value. If we hit run again, you will see it goes from 0 to 24. So meaning if we change this begin value, nothing will actually happen. If we change the set state to actually change the beginning value, no change will occur on screen. It will only animate or interpolate if the end target changes. Another thing to note is that the value will change dependent on what the current value is. So as an example, if we click this and then midway through click it again, then you can see it stops the animation midway through and then animates back to the beginning. So it basically allows you to change it on the fly. And this will be more evident in the slider animation or the RGB slider example that I made. Okay, so here we have the RGB slider. And as you can see, we have red, green, and blue. So if we drag the red slider all the way to the right, you can see it starts to animate from the black value to the red value. And the same for green. If we add green to the red, then it will be yellow. And if we add blue all the way to the right, then this will be a white color. So this is a good visual representation showing you that it animates it on the fly. So if we change the values as it is animating, then it will automatically update as it is transitioning. So the code for this is quite simple. We have 3 instance variables, a red, green, and blue slider. And these values are handled by these sliders that I've created. And this onChange will just update the value to reflect whatever is currently on the slide. So as an example, the value over here will be a value between 0 and 1. And then we set the green slider, in this case, to a value between 0 and 1. And then we call update color. And all 3 of these sliders do exactly the same thing. And in update color, all we do is we call set state, and then we update the end color to reflect the new RGB values. Because this is a value between 0 and 1, we multiply it by 255 to reflect the RGB scale, because an RGB value would be between 0 and 255. And then we just call toInt on this to make sure it's an integer. And then the actual animation happens within the tween animation builder. Here we have a tween, and it's a color tween, and we give it a begin value of white. So as an example, if we click run, the beginning value will be white, and then the end color will initially be black. And as we change these sliders, it will update the color to reflect whatever slider value that we change. And you can see we have a duration attribute. So if we set this to be 5 seconds, then it will just take longer to interpolate between the different values. And this is a good way to illustrate that as you drag these sliders, it will change them on the fly while it's still busy interpolating to the old value. We will go back to the original example, the example that's given on the Flutter website. And I would like to illustrate that we can also pass in a child attribute. As you can see, here we have the tween animation builder, and the tween animation builder has a variety of different attributes. It has the tween, the duration, the builder, which tells the widget what to rebuild when the animation changes values. And then we have this child attribute. And this child attribute is the actual icon that you can see on the screen over here. And this icon or this child attribute gets passed in as a widget to the builder. And then within the builder, we are actually giving it the child as the icon. So technically, we don't actually need this. We can copy this out and then comment out this field. And then instead of passing in the child, we don't need it. So we can just make it an underscore. And then we can give the icon value over here. And if we click run, this will still be exactly the same. So now the question is, why do we actually want to pass in a child attribute? And that is because if we pass in the child attribute, as we originally did, that will allow us, or that will allow Flutter to just build this widget once. So now if we pass in the child, instead of creating the icon on every single animation tick, it will give us some performance optimizations, as it will mean Flutter will not need to rebuild this icon widget every animation tick. Instead, it gets built once, and then the child just gets passed in. I encourage you to read the performance optimization section over here, and that gives you further details on why you would actually want to pass in a child attribute. This is only really beneficial if it's a complicated subtree. So for example, if it's a widget that has a lot of children, or if it's something that will require a lot of computational resources to build. Something like an icon won't require a lot of resources, so you might not actually see any benefit. However, it is always best practice to pass in static attributes as a child attribute, or these animation widgets. And in animation widgets that we will explore in the future, you will note the child parameter again, as this is a common performance optimization technique. As a very last thing, we can also pass in a curve. And now you can see that it has a different curve attribute. A tween animation builder also has an on-end value that we can pass in. And this is just a function that gets called on the end of the animation. So here we can just say print, and we can say finished. And if we look at the console, then you can see as the animation is finished, finished gets called. So let's say you want to create a repeating animation. You might think onEnd is a good place to do this. So every time onEnd gets called, then we just update the value of the target value. So as an example, we can just call setState again and put this here. And if we click run, it should be a looping animation. And there you go. Now we have a looping animation. However, this is not ideal. It would be preferable to use other animations that are built into Flutter to achieve looping animations. The tween animation builder and implicit animations are only really useful for once-off animations or animations that can be controlled by some user-controlled value. Yeah, that is that. I hope you found all of this useful, and implicit animations really do provide you a lot of value. But in the upcoming videos, we will be looking at how we can create our own custom animations completely from scratch, and those are called explicit animations. This is where the real power comes in, and this is where we will be flexing our own animation muscles to do some pretty cool things.